Okay, now let's see some approaches that we can use to classify production system according to their characteristics. The first relevant approach that I want you to be aware of, or maybe you're already aware of, try to distinguish production system according to their way to manage the delivery time and satisfy the demand. In particular, let's compare the due date in which the customer expects the order to be delivered with the day in which the customer in practice expressed the order to the company. When the date of the order is very far from the due date, the company can produce according to what we call an engineer-to-order approach, meaning that all the activities needed to produce, so engineering, purchasing, manufacturing, and assembly, are executed on an order basis. There are instead cases in which the date of the order is not so far to allow the company to start from the engineering, and so the concept and the design of the product needs to be already in place. But then, purchasing, manufacturing, assembly can be executed on an order basis. This is what we call a purchase-to-order system, so where purchasing, manufacturing, and assembly are executed after a customer order has been put in the system, and the engineering, the concept engineering and the design of the product has already been made. Going on, there are cases instead in which also purchasing need to be managed on a forecast basis because the date of the order put by the customer, the date in which the customer put the order, doesn't allow the company to execute purchasing after this order. So in this case, purchasing is managed on a forecast base, but all the pure production activities like manufacturing and assembly are executed after the customer order is evident. This realized what we call a make-to-order system. Finally, there are cases in which the date of the order is even more proxy, and also some production activities need to be realized upon forecast. This is the case of what we call the assembly-to-order system, where manufacturing after the order is evident is no more possible, but it's just possible to postpone the execution of assembly activities. So in this case, just assembly activities are realized on an order basis, while engineering, purchasing, and manufacturing are also made according to forecast or to plan. Finally, there are cases in which there are no possibility, or it's company choice not to work for it, to execute activities on an order basis. All is made in advance and according to forecast, realizing what we call make-to-stock system. So all engineering, purchasing, manufacturing, and assembly is made before the customer has put an order and stored in buffer or in queue areas in order then to satisfy order once they will be evident. Typical engineer-to-order context are all the construction project-based companies. So all the companies that realize bridges, trains, new buildings, and stuff like this usually do that through using an engineer-to-order approach. A purchase-to-order context instead can be, for example, the manufacturing of a yacht. The companies have already the concept and the design of possible model already stored and conceived. But purchasing, manufacturing, and assembly of this type of product is made once the customer has put its order to the company. The make-to-order context instead is typical of the restaurant or fresh food industry. Here, it's funny, but think about a wedding cake. The wedding cake, to do the wedding cake, we already know the concept, we have all the raw materials, but we manufacture and we assemble the wedding cake after that we receive the order from the customer. While the assembly-to-order system is the case of car manufacturing. All the components are already manufactured, and car producers like Chevrolet, like Porsche, like Audi assembly cars on an order basis, especially if we are referring to very luxury model of cars. Finally, the make-to-order system is typical of the retail market. Here you see a washing machine, dishwasher, clothes, toys. So all the retail market usually sells product to the market using a production system which operate on a make-to-stock logic. Besides that, besides distinguish the production system according to the way they manage the delivery lead time and they manage reaction to customer order, we can also distinguish the system according to the technical characteristic of the production process. First of all, we have what we call production industries like the cement or the paper, where we have continuous input which generate continuous output. So in case of the paper, we have different type of raw materials which are continuously input in a paper plant in order to produce continuous output. So different type of paper on a continuous basis. Then we distinguish the process industries to the discrete manufacturing industries. Discrete manufacturing industries, which can be in this case car or trucks manufacturing, where we have as input what we can call discrete units. So we have the different components to manufacture and to produce car or trucks, like brake, engines, steering, wheels, and tire, and so on. And I mean, in output we have single discrete unit, the car, one brake, one car, one wheel, one car, one seat, 4 seats, one car, and so on. So discrete units of components in input and discrete units of finished product in output. Why I'm saying you this? Because we have also another type of process industries. We have other type of process industries which are, I mean, different from the previous one. Previously we mentioned cement or paper or also aluminum and so on. In this case, we are considering process industries that in input sees batches of raw materials. This is typical of, for example, the clothing, the clothes manufacturing. In input we have woven, we have textiles, we have colorants, which are input to the production system in batches. Using batches of woven, textile, colorants, and so on, in output we obtain batches of final product. We have batches of t-shirts, we have batches of shirts, we have batches of trousers, all coming from the batches of input that we put in the system. If you have understood the drill, we have also another type of discrete manufacturing industry, which is different from the previous one that we mentioned. For example, previously we mentioned car manufacturing, car assembly, or also dishwasher assembly, and so on. White goods assembly is all falls within this type of discrete manufacturing industry. There are also other type of discrete manufacturing process, which instead sees in input batches of discrete unit, so batches of discrete components, giving in output batches of finished product, so batches of single units of finished product. Think about, for example, the office or home furniture industry. In input we have wooden, other materials to manufacture and to realize benches, chairs, and beds, and in output we obtain batches of chairs or beds or benches that comes from the same batches of components and raw materials. We can cross the classification according to delivery lead time and the process type, also including a third dimension, which is the characteristic which are the characteristics of the product. So of course this is the classification of the production system according to the delivery lead time, and this is the type of manufacturing that the production system is serving, and we can also include a product dimension distinguishing between simple product or complex product. Simple product, of course, are products made by few parts and very easily to be manufactured, while complex products are products that have many components and have also different complex activities to be performed in order to arrive to the final configuration. And using these three axes, we can classify every production system for every type of product. I just make you two examples. Just consider shoes and water. Shoes are, an average complex product because they are made of different type of raw material, different type of activities, have different parts. They are realized through discrete manufacturing, so they are a discrete production, and usually companies producing shoes use a make-to-stock approach. Look instead what's happened with water. Water is of course a simple product realized to continuous or process production, and also in this case a make-to-stock system is used to produce product according to the expected delivery lead time by the customer. So according to this three dimension, whichever product you can imagine can be classified according to this axis.